morning or afternoon, depends on when you're watching this. We are going to be looking at 12.2, day 1. We're going to be looking at arithmetic sequences in series. Now these are special sequences in series, and notice the word arithmetic. That usually means we're adding or subtracting something. So what is an arithmetic sequence? It is the difference of consecutive terms is a constant. So for example, if you look, you've got 2, 4, 6, and 8. We're adding 2 each time. So the common difference between those two is actually, and we use the letter D to express that, the common difference is 2. And you can see this is a sequence because we're not adding. It's not a series at this point in time. So the sequence is the difference of consecutive, that should be a C, terms, is constant. 2, 4, 6, 8. And you need to find out what that common difference is, and it's 2. And we have a formula coming up where you're going to actually see. So we look at these and we want to figure out whether or not they are arithmetic. Move this over just a little bit. Are we doing something to each term to get the next one? So for example, how do you get from -3 to 1? Well, if you start with this and you go backwards, if you say 1 minus a minus 3, that would be 4. 5 minus 1, that's 4. 9 minus 5, that's 4. So the common difference for that one would be 4. So that is arithmetic. So let's come over here. 5 minus 2 is 3. 10 minus 5 is 5. 7, no. We don't have a constant. So that is not arithmetic, and that is arithmetic. And in this case, D is equal to 4. A rule for arithmetic sequence. Okay, I'm going to give you a couple seconds to write that down. And let me explain what these things say so that you actually have the right letters. This is the nth term. That little subscript means it's slightly below, is the nth term. This will generate whatever term you're looking for. If I want to find the 60th term, I could find it using 60 here. The first term, the very first term, now if you look up here, the very first term was -3. That's going to be a number. And then we add to it the number of terms that we're looking at, -1 times the common difference. We have to find the common difference. So this will help us find out what the rule is that we're using. This is something that we had to figure out before just using our head, but now we have an actual formula that will help us do this. Write a rule for the sequence 50, 44, 38, 32, and find the 20th term. If we were to do this all the way out, find 20 of these terms, that's what we're going to be doing. This is a shortcut because it would take a while to do that. So the rule for that, the first thing we know is that the first term is actually 50. 50 is our first term. So we have this. We're looking for the first off the rule, and then we're going to find out what 20 is for it. And what do we have to do? 44 minus 50 is -6. 38 minus 44 is -6. That's the common difference. It's negative because we're going down. It'd be positive if the number was increasing, but it's not. So now we have our formula. A sub n is equal to a sub 1 plus n minus 1 d. Substituting in there, we have a sub n is equal to 50 plus n minus 1 times -6. There's our rule. We substitute it in, and that's how we would find now. What we're going to do is find out what the 20th term was. Oh, and here this is simplified. 50 minus 6n plus 6. See, what we did was we distributed that through, and combining like terms, this is the final rule. A sub n is equal to 56 minus 6n. That might have been hard to figure out on our own starting out, but this makes it much easier to do that. And then to find the 20th term, you substitute into this formula, 56. See, I put the 20 there to tell me. This is just a name. I'm not doing anything with the 20 here, multiplying. It's just the name. The 20th term is equal to 56 minus 6 times 20. So if we were to do this all the way out, when we got to the 20th term, it would be negative 70. Now here's a point where I would ask you if you had any questions, and I'm really sorry that you're not here so that I can answer any of them. Okay, let's turn the page and take a look at the next set of information. Write a rule for the nth term of the sequence and then find the 25th term. Okay. We need to find out if it's an arithmetic sequence to start off with. And it is. We're adding 2 each time. So D is 2. And let's look at this one while we're at it. This one, let's see, what's 23 minus 9 is 14. 14, 14. So D is 14 for that one. The first term for this one is 1. The first term for that one is 9. I'm sorry, I'm kind of doing these at the same time. So D is 2. And I think what I will do is cover that one up while we're doing this. So D is 2. Substituting into the formula that we have, A sub n is equal to the first term, n minus 1 times D. This will always be n minus 1. Distribute the 2 and then combine like terms, and we get what will generate this? 2n minus 1. We want to find the 25th term, so this will be a sub 25 is equal to 2 times 25 minus 1, which will be 49. The 25th term, when you go out all the way out, is going to be 49. Okay, now this one we said D was 14. The first term is 9. So we plug into the formula. A sub n is equal to 9. Remember, that stays n minus 1 times 14 because the difference is 14. Distribute the 14 through, combine like terms, and we get A sub n is equal to 14n minus 5. Now we put the 25 here to find out what the 25th term is. 14 times 25 minus 5 is 345. I find this is probably a little bit easier than what we did on the last section, because now we have a formula that we can use in order to do it. All right, let's move on. Now we want to write the rule for the term, let's do this one first, of the arithmetic sequence. So basically now, instead of having it generated for us, they're telling us this. Kind of makes it easier because we just have to go into the formula. A sub n is equal to the first term, n minus 1, that stays the same, times D, and then you just solve it. And there it is. The nth term is negative 12n plus 92. Once you find D and you have the first term, it's all just substitution into that formula. This one. All right, so we need to figure out, in this case, if the fifth term is 17 and the 15th term is 77, we actually plug those values in, and we find that A sub n is, the difference between them would be 6, and we would be starting off in negative 7. they're 10 apart and there's 60 of them, and so that means that the difference would be 60 divided by 10, so that's 6. And when we go back to find out what we're doing to get to the first one, it would be -7. So we plug that all in. This one's a little bit trickier, and we get a sub n is equal to 6n minus 13. Okay, not so bad. I think this is a little bit fun for me. Take care of yourselves.